Testing 1, 2, 3, testing 1, 2, 3. Okay, guys, can you hear me? Okay, great. Okay, so today's the last lesson, and what we are going to go through will be, of course, this set of slides, but I'll not be going through everything. Okay. Okay, I'll not be going through everything here. So I'll just probably go through the first half, and then we will move on and then we will move on to the paper, okay, to the exam like questions found in your study guide. Okay. Yeah, so that's what we will do, right? And after that, I think that will be the end. Okay. Have you started on your assignment already? Yes. So how is it? Good? Simple? Okay, 1 or 2 questions. Can. I think we'll leave all the assignment questions to the end. Is that fine? So first half, I will cover this over here, okay, and then we'll run through the paper, okay, and then second half, okay, or third half, whichever's left, you can ask questions about assignment if you have questions, okay. Okay, so this part here, I won't be running through everything. I will let you know why. Okay. Of course, when I do certain things, I'll let you know why. Okay, so in this case here, we'll run through the examples. The examples are to prepare you for your exam. Okay. So what's in for your exam? Okay, maybe let's run through examples first. Then later on, I will tell you what to look out for in the exam. Okay, so after learning Python, you will be able to do numerous programs, right? So if you have take time to look into it, you can actually plot graphs, you can actually do web harvesting, do data analytics, okay? You can even do web programming, okay? So you use Django, use Flask, okay? You can actually do web programming. So there's a lot of things you can actually do, okay? So one of the examples we're going to see here will be the obscenity detector, okay? So what is here, what is important in this particular topic here, or in this particular example here, is to see his thinking process, okay? How he creates a program, okay? How he creates the program. So you have something in mind, okay? You have a challenge in mind, okay? I want to create an obscenity detector, okay? So then, of course, you define what the obscenity detector means. Is to create program that checks if the text is in the file contains what we call forbidden words, okay? And then it should inform the user if the file is safe or unsafe, okay? And of course, you can do a step, further than that. You can actually replace all those vulgarities or unsafe words with other words, okay, or other things like XXX, just to tell that this is a obscene word, okay. But for here, we'll just inform the user whether it's safe or unsafe. Okay, so for the pseudocode, you read the file name from the argument. That's what is okay. So his first step is to read the file name from the argument. If there's no file name, then the program cannot proceed, so he quits. And then after that, if there is a file name, and if he can open, okay, for every line in the file, for every word in the file, then he will check for every line in the file, for every word in the line, if the word is forbidden, then the file is unsafe. Okay, otherwise the file is safe. Right, so if you look at this, he has the UML workflow. Okay, this is what you're going to do for your exam. This is what you're going to do for your exam. Okay, the UML diagram that the exam wants is the flow of your program. So if you're asked to create a UML activity diagram, is something like this. It's a flow, right? So you need to have the correct symbols at the start and at the back. Okay, and of course the triangles, the rounded rectangles. Okay, this is the parallelogram. Okay, diamond shape. Okay, and other stuff, right? So the flow must be correct. So here you'll check whether it's 2 arguments. If no, print the usage and then the program ends, right? So this one means program ends. Then it will if your program has 2 arguments, right? Then you will try to open the file. Okay, this part here didn't check whether the file is a valid one, so it assumes that the file is valid. And after that, if there is no, you check that for every word. Okay, if it's forbidden, if no, you will keep on looping. So you will loop every word in that particular line, right? You will loop every word in a particular line, and if that at the end of the line itself, let's say there are 5 words, these 5 words are not obscene, it will loop back and check for the second line, and second line will check for every word, check whether it's forbidden. If not, you loop back again and check for the 3rd line, 4th line, 5th line, in that manner. So eventually, if there's no forbidden words, then we can be sure that the file is actually clean. So the program will end. Okay, if in any case that the word found is forbidden, there's no need to iterate anymore. You can just go down to file is unclean and end the program. Okay, so you can see that there is particular there is a flow over there to indicate whether this file is actually clean or unclean. Yes, any questions?
Sir, is there a certain flow that it should be like going landscape?
Sorry.
Because
Give me a moment. Sorry. You keep a question for a while. Give me a moment. It's too soft for me. I will put on my earphones.
Okay, yeah. So you can speak now, because if I turn on the mic too loud, then you will hear yourself. Yeah.
Okay. Sir,
Yeah.
is there a certain format for this UML flow diagram? Because for the car rental, right, it was going sideways, or is it depending on us?
Ultimately, there should be a start and there should be an end. Logically speaking, is either top to bottom or left to right. So as long as you have the terminating points and the correct shapes in between, that's okay. So logically, we'll read from left to right or top to bottom. So it's fine to put either ways.
Okay. Understand. Thank you.
Okay. Yeah. Just don't put the starting and the ending at the same place. So you don't put both at the top. Then it becomes confusing. You understand what I'm saying, right?
Yes. I get what you mean. Thank you.
Okay. Okay, so he has this particular example over here. So he checks that if the length of the arguments is not equals to 2, then you will print the usage and then quit. Okay, he will list a list of forbidden words, opens the file, perform a split, okay, and if the word is in the forbidden list, so let's say, for example, if there is a FCK inside, okay, then you can print that the file is actually unclean, and then you quit, okay. Otherwise you can print the file is actually clean. Okay, we could definitely do better than what he has, but he's, I would say, is a pretty straightforward program. In the exam, you don't have to do too fanciful stuff unless the question is long. If the question is long, then you'll be better if you put them into functions. If the question is not long, short question like this, you don't have to really put them in functions, because you'll probably cost you some time. But for people who are used to functions, functions are actually faster for them. Okay, so functions are actually faster for them. So so again, I would say it depends, but in exams, do what you need to do to get the to get the answers, no, to get the answers going. Okay, is your exam an online exam? Is it an online exam? Believe so. Okay, yeah. So be careful. I know some may talk to each other, right? And some of the answers may look the same. Okay, so you all should be careful about that. Okay, so because ultimately, when it comes to this type of cases, if it comes to plagiarism, I think they are very, very strict about it. Okay, so if they detect, then I can't help. Okay, so please try to do on your own. That's what I can say. If it's an online exam, if it's an offline exam, then not an issue. If it's a face-to-face exam, then everything is simple. But I believe it's an online exam. Okay, so it's good to write down the answers, in, let's say, I think, yeah, on paper or document. Okay. All right, so let's move on. Okay, from this, later on we will try to put this into the pie chart, just to run this, okay, to satisfy our curiosity, and then of course to try to make it a bit better. Okay, so you can see this is a test file 1. This Python SHT is complicated. Okay, test file 2, this Python stuff is complicated. So you run the detector, and it shows you the usage. You can see this one is actually wrong. This is actually wrong. Okay, it should be obscenity detector.py. Okay, so you run that obscenity detector again and pass in test1.txt. Then it tells you that the file is unclean because it detects SHT. Okay, you run on test2, it shows you that the file is actually clean. Okay, so you should test multiple files, multiple cases, not just one. Okay, when you have a test file tree like this, and the SHT becomes uppercase for S, okay, the detector cannot detect that this is a vulgar word, so it still say the file is clean. Okay, so you can see this one is also clean, although there is a obscene word over here. Okay, obscene word over here, because the FCK is having, when you split it, the last one is actually FCK exclamation mark. So there is an exclamation mark at the back that's causing the problem. Okay, so we need to test. Okay, so we found that, okay, the example that we had was not exactly good, so we need to test. So we came up with the further code. So what he's trying to tell you is that you need to come up with test cases run them, make sure that all the scenarios work before you can say that the job is complete. Okay, if you do not test properly, then there is a problem. Okay, there's a problem. Okay, so now there are two things you need to do. First of all is to set every word in the line. He will set to lowercase. After that, he will remove all the punctuations, okay, itself. Okay, you will remove all the punctuations itself, okay, in the case. Okay, and then you are only left with the word. And if it's still found in the forbidden, then of course the file is unclean, okay, and then you quit. Okay, so when you run it again, right, when it runs it again, you can see that it's able to detect SHT and FCK exclamation mark. Okay, so you can see that he did a few tests over here and there. And this is the final this is the final piece of code. Okay, we will try to refine this code a bit, okay, just to satisfy our pursuit for so-called better looking code and easier to understand code. Okay, if you look at this, it is not that easy to understand from one look. Okay, so I'm going to show you how you can actually put them into functions, tweak them so that it's easier to read. Okay, but again, if it's exams, you don't have to do that. But if you are used to it, of course you should do that, because functions will help you make your code easier to read. Okay, obscenity detector, so the complexity, m lines of n words. So is it ON square? Not really, because what matters is the number of words. So for every line, it says that it is the number of words, right? So are you detecting n words? So n words in total, examine each word once, so ON. Okay, so basically m lines of n words each. The complexity is actually ON, not ON square. Okay, because there could be 3 lines, but then 100 words. Okay, 3 lines about 100 words, right? So the thing that matters is not the line. The thing that matters is the number of words, right? So all in all, the ON, the big O notation is ON. Okay with that? Any questions on this? Okay, if not, then we will move to our, okay, we will move to convert these just to make the code easier to read a bit. Are you okay with that? Okay, let me just shift this. Okay. Okay, so I'm going to do it step by step, so you probably understand what it's trying to do. All right, so let me take a look at his code. Okay, so he need to import sys. This one is meant for the arguments. And then he started to check whether the arguments, the number of arguments is 2. Okay, so we could actually put a main to make it easier to read. Okay, so this part here, okay, I'm going to write what he writes first. Then after that, we think about how to make it easier. Okay, let's copy this part over here. Okay, I'm going to do a bit of conversion from here. Okay, so this is his code. Okay, so let's just run his code first. Okay, let's just run his code first. But of course, I need the test file. Okay, so I'm going to put in a few test files. So this one will be test1.txt, test2.txt. Okay, I think it's harder if I do this, will be easier. So I have test1, test2, right? So I have touch test3.txt, touch test4.txt. Okay, so I should have 4 files by here, right here. Okay, so I'm going to copy some of the test case over. So this is the first test. Second one. Test file 2. Okay, so this one should be deleted. This one should be deleted. So you have the test 3. And then test 4. Okay, so if we did not write this, okay, simply okay, let's try to dissect this one first. Okay, so this one is saying that if the length is not equals to 2, so this part here I will just comment off first. Okay, and put in, okay, arguments are correct. So let's try to dissect this part. So we do Python 3 obscenity py, okay, and it tells you usage obscenity file, right? So I could put in a file name. Okay, so again, if I do this, okay, I think this is easier to read. Okay, and of course, you want to give examples, you could actually do that. Python, I call it Python obscenity detector.py. Okay, for example, test1.txt. Okay, something like this. Okay, so let's run it again. Okay, make it easier to understand. Okay, sorry about that. Yeah, so this one will show you that this is the example to use. Okay, so let's get it correct first. Okay, and let's put in a file name, let's say test1.txt. Okay, so it works for us. Okay, arguments are correct, so this is correct, so we can throw this away. Okay, so next, what he wants to do is to be able to open a file, right? So this part here is really to test for arguments. Okay. I will mute the person. I think don't know what happened. Okay. So so for this part here, next part, what he wants to do is to set up, okay, run through each line, okay, and look at each word. Okay, so we will first of all, we will try to open the file. Okay, try to open the file. If file opens, run through each line and look at each code. So what he did was he did a direct open over here. Okay, so I'm going to follow his code later on. I'm going to change. This one I'm just trying to show you what he's thinking over here. So for each line, okay, he's trying to print the line. Okay, so I'm going to try to print the line here. So let's run through this. Okay, it shows you this thing is complicated. Okay, so I can put in this is my first test file. Okay, I am pushing, okay, something like this. Okay, so if you run it, okay, it shows you 3 lines that you have run through each of them. Okay, so it is okay, but then we want to be able to get each word, right? So we want to be able to get for, okay, so for word, okay, if you split it up, it'll be easier to read. Words equals to line dot split. Okay, so this one is to break the line into words array, words list. For word in words, print word. Okay, so for words in words, print word. Okay, so this part here, if we run it again, okay, it shows you oops, sorry, I think I wrongly. Okay, it does, what it does is that it will take each word and print on a different line. Okay, so that means we are able to look through every word in the list itself. Okay, we can look through every word in the list itself. So this is good. Okay, this is good, but I'm not too satisfied with this. Okay, I'm not too satisfied with this open file over here. Okay, later on we're going to make some changes. Okay, we are going to make a bit of changes here and there first. Like for example, changing this to make it easier to understand. Okay, or this one, if you are words list. The other time I use words list or word list, right? They use a list, they use this, or they use just simply words. Cannot remember. Anybody? Don't remember. Okay, I think to prevent words list, okay, to prevent any confusion, because some of you cannot see the difference between WORD versus WORDS. So I put in a list to say that this is a list. Okay, so this one is to print the word. Okay, after that we will check, right? Okay, we will check. Let's say, for example, okay, so you have a forbidden list that we want. Forbidden list. Okay, so this is the forbidden list. So we say that if word in forbidden list, print file is not clean, and then he simply do a quit. Okay. Okay. After the everything, if you run through everything and every word is no, it's not, every word is definitely not found in the forbidden list, you can print that the file is clean. So that's what it's doing. Okay, so if we run through this again, it will show you that the file is not clean. Okay, run through test2, it shows you that the file is clean because test2 is a good file. Okay, so test2 is a good file. Okay, so that's what he's trying to do so far. Okay, based on example. Okay, and after that, he finds that once you run through this, right, run through file number 3. Okay, once you run through file number 3, you find that you will still say the file is clean because your SHT and the FCK are all in lowercase. So I need to do a lower, okay, and so that for every word now it'll be lowercase. Okay, oh, it's because of the commas. Okay, let's say if I remove the comma, it should work. Right, so it says that file is not clean. Okay, so the uppercase does not matter anymore because we change all the word to lowercase. Right, we change all the word to lowercase. Okay, and we know that the commas, all these will make all these not work properly. Okay, so that's why he added this last part to strip. Okay, to strip the punctuations. Okay, so far okay, right? I run through most of the stuff, right? This part here is just to add, and then if you run it again, it will show that the file is not. If you put in a comma now, okay, even if you do this, it will show that the file is not clean because it's now able to remove the comma, set this to lowercase, okay, and then tell you that this is not clean. Okay, so this is the original code. Okay, this is original code. I'm doing part by part to show you what he's trying to do. Okay with that? Any questions here? Any questions over here? No? No? Okay, is this easy to read? Not too easy to read, right? Okay, so what we can do is, I think the length part you can still leave it as it is. Okay, but if you really want to you really want to put it in a function, you can actually do that. Okay, so this part here is to, let's say, I'll say that this is to test the number of arguments. This part here is the set the forbidden or create so this part here I will put it right here. Okay, this is check for the number of arguments before you construct the list of words, and here you try to open the file. All right, okay, so I will probably do it this way. Okay, so this part here, I will just return true or false, right? So if has valid okay, so this one has to check, right? If not number of valid arguments, just perform a quit. Actually, I wouldn't want to print over here. So this part, yeah, this part is redundant. Not redundant, but I should just put it right here. Okay. Because he wants to quit, because based on the thing here, this one wants to quit. Check for arguments. Okay, so check for arguments. Okay, so this part here, once let's say it's wrong, it will simply quit, right? So let me just try to do that. So it will still give you the correct correct usage. So you can see that it's working fine. Okay, this part okay, right? So check for the number of arguments. Okay, second part here, you are only building a list based on what you know. But what happens if you want a list that's built from a file? Okay, I'll not be going through that. I'm just saying that if this is the case, I would have a forbidden list that will be built from a file. Okay, the third part here is, I mean, there's a number of improvements we can do. First of all, we want to try to see whether we can open the file. If we cannot open the file, we should exit the program, right? So if we can open a file, then we will get the word list. Okay, so we will try to do what we call words. Let me see. What should I do here? Dot split. Okay, so for this part here, we can try with open instead of this. Okay, with open the okay, so I make it readable. So we've open file name as in file. Okay, so this will be slightly better. Okay, because just now when you open the file, he did not close the file. Okay, so with the with, you do not need to close the file at all, okay, because you automatically close for you. Okay, it will automatically close for you. Okay, so this part here, actually we can put it in a function again. This part is probably the one that looks a bit more complicated, right? So what I'll do is open file, read. Wait, let me see. How should I load? How should I load each of them? I open a file, put inside the list. Okay, so this part here, we can say if it's forbidden word file is not clean. Okay, so we can create a function in forbidden list. Okay, so we can put this. Okay, if the word is a forbidden word in the forbidden list, print file is not clean, quit. Does it make it easier to read now? Or is still complicated? Does it make it easier to read now? Slightly better or no improvement? A bit lost. You too, okay. So the original code is better, is it? That's what you're saying. The original code is easier to read. Okay, never mind. I'll start from scratch. Okay, I'll do a quick one. The original code by him is easier to read. This is easier to read. Okay. Easier for you, but not so reusable lah. They're not so reusable. Okay, not so reusable because they are not in functions. Okay, they're not in functions. Okay, never mind. I think then I'll just leave you to this. Since you understand this, if I go further and it makes it difficult for you, I will just probably stop here. Okay, everyone can understand the original version, right? I'm just trying to improve the code, but then to make it reusable. But then again, I see a number of you are having trouble trying to understand what I'm trying to do here. Okay. Any is this okay? Then I'll just do this. Any questions on this original file first? As in original code. No. The rest all okay, yeah? So Denise has no problem about what about the rest? Nikki also no problem, right? Jenny? Jenny, any problem? If you refer to the original code, any problem for you? No, huh? Okay, then I will not then we will just refer back to the original code, right? Just refer back to the original code. Anyway, the example ends there, right? The example ends here. If this is the code that you can read, I will just do with this, right? I'll probably show you an improved version if I have the time to code that. Okay, otherwise you just stick to this. So okay, so I'm going to continue. Is that fine? Everyone? Okay. Right. So for his example, he didn't put in functions. I guess you are not too ready for that as well. Okay. After all, the course doesn't really talk too much about functions, only for one chapter. So I can't expect you to be able to write a function suddenly, right? Okay. So there are examples asking to write a function to calculate the the time, to calculate the factorial of n. Okay. And then it will be undefined for negative numbers. Okay. No, it's okay. It's okay. I mean, is something that takes time to understand, right? It takes time to understand. So initially, most of the time, people will just build a very long piece of code. Eventually, they find that they need to build functions. Okay. Okay. So for this set of slides, I will run through this example, and then after that I'll stop. Okay. After that I'll stop. Okay. Factorial example calculation. So just now we ran through the obscenity detector. Factorial function, you are supposed to write a function to calculate the factorial of n. Say, for example, if it's 5 is 1 times 2 times 3 times 4 times 5. If it's 0, it will simply be 1. If it's 1, it's simply 1. If it's 2, it's simply 1 times 2. Okay. And is undefined for negative numbers. Okay. So the function will be supplied inside a module. Okay. So what he wants you to do is to write a function right now. So your pseudocode is to check if the number is 0 or more. If not, inform the user there's an error. Okay. If the number is 0 or more, then it can continue. Otherwise, inform there's an error. Okay. Start with a result of 1. Go from 2 until n and multiply with the current result. Okay, so let's take a look at his code over here. Okay, I would probably do something different from him. Okay, then you see whether it's easier for you this time around. I'm not going to change too much from him. It's just that I find his function is trying to do too many things. Okay, okay. So first, he checks whether n is smaller than 0. If n is smaller than 0, error goes to the end of the program. If n is 0 or above, then he sets result equals to 1. For value in 2 to n, he will multiply by the result. Okay, why he does that is because if let's say you key in 0, result will be 1. For value in 2 to 0, okay, it will straight away exit and then return 1. Okay, if n is 0, right, it doesn't go to error, right? If n is 0, he will set the result equals to 1. If n is 0, the for loop will not execute. You simply go to return result, which is 1, and then you print, right? And then you return to a calling function, and then you print. If the n is 1, result is still 1. 2 to 1 for value in 2 to 1 is also not going to execute. So you'll go to return result, which is also 1. So for cases of n equals to 0, n equals to 1, result will be 1, and then straight away return result. In the case of n equals to 2, result equals to 1. So for value in 2 to 2, so 2 to 2 is okay. Okay, so it will be result equals to 1 times 2 because your value is actually 2. And then you look back, okay, then it checks that it will be out of the loop, then you return result, which is 2. If, of course, your n is 3, then you will go in result equals to 1. From 2 to 3, result equals to 1 times 2, which will give you 2. Look back, result equals to result times 3, that will become 2 times 3, which will be 6. And then you exit and then return result. So you can see that the logic actually works. You keep on multiplying the value until the end, and then you get the final result. Okay, so he does have a few things. He checks that if n smaller than 0, return no negative factorial. Okay, actually, this, in most cases, we shouldn't return any string. Okay, we should return a result itself, and the checking of this number shouldn't be inside the function. Okay, shouldn't be inside the function. Okay, I will just change this a bit. Okay, later on, most of it will be the same. Okay, result equals to 1 for value in range of 2 to n plus 1. Result times equals to value, return value. Okay, so we will run this. Okay, so when he puts in 5, the result is 120 because 1 times 2 times 3 times 4 times 5 is 120. Put in 0, the result is 1. When he tries to put in -1, he shows you no negative factorial. Okay, while the result looks okay, but I said I think that this shouldn't be in. So how do we deal with that? Okay, we will see that in a while. Okay, we put in factorial.fact 3.14, factorial.fact something. Okay, you have a problem with types. Okay, so his function is trying to deal with too many things, like I said. He's trying to check whether it is a number. If it's a non-integer, he will say that it's a non-integer. So you shouldn't have, you are going to raise an error over here. If less than 0, you raise a value error to say that it's a negative value. Okay, like I said, it's trying to do too many things at one time again. Okay, I probably wouldn't do that right here. Okay, I probably wouldn't do this here. Your function gets a bit bloated lah. Okay, a bit bloated. Okay, so he has one documentation over here. So this is what we call the doc strings. It return the factorial of integer greater or equals to 0. So when we do a help, it shows you that, sorry, it shows you this particular message. Okay, so is the example still easy to understand? Still okay, right? Still okay, right? Still okay, all of you okay? Okay, right, so let's try to run the example, and I'll try to shift this out. Okay, let's move that. So Denise, okay? Yes, okay, so let's run this. Okay, so for his factorial, I call it math functions. Okay, I will call it factorial. Okay, n is all right, although I'll prefer to call something else, but n is normally okay. Okay. Okay, so I should print 120. Okay. Okay, so how do we do it? So normally we will check, right? Based on his notes. He will set result equals to 1 for I in range of 2 to n plus 1. Result times equals to I. Okay, so you call this value. Okay, I call this I. Okay, and then return result. Okay, so if you run this, it will show you 120. If I run, if I say factorial result, this one should give me 1, and this one should give me 1. Oh gosh, why is that so? Oh yeah, because this is 2 and this one is 3. Okay, so far okay, right? No problem, huh? So all is okay, right? Okay, if you are trying to use the function, normally I would not put in the try here. Okay, let's say for example, this is what you normally do. We will say that number equals to integer input. Okay. Okay, let's say something like this. All right, so this is your number. Okay, and I will not do the validation here. Okay, I will not do the validation here. Okay, I will try to check if is valid integer or valid positive integer. Okay, then I will get the result equals to factorial okay. Right. So do you understand? Do you understand what I'm trying to do? This is, I didn't write this thing yet, but this one is for checking whether this one is an integer. Right. So I'll do the checking outside. I'll not put it inside. Okay, this one is to check whether the input is an integer. If it's an integer, then you pass it to the factorial to get the result. Otherwise, do this. Because when you put everything inside this factorial, then it gets bloated. Number one. Secondly, you are doing checking over here, and based on functions are supposed to do one thing only. In this case, it's supposed to do calculation of factorial, not to test for user inputs. You understand what I'm trying to say? If you're trying to do too many things at one time, your function is basically wrong. He's trying to do the testing, then after that, calculating. So do you understand why I'm putting them away? Yes or no? No answers. You think so, huh? What about the rest? Okay, so this part here I'll do for you. Maybe you understand better, okay? Okay, so this part here, I will put in yes, functions are supposed to do one thing at one time. Give me a moment, give me a moment. Hello. Sorry. I got need to open the door. Okay. So yes, your function is supposed to do one thing at one time only. Okay. So I'm going to put in. So is it okay? I continue from here and see whether you understand. Okay, so what you are trying to do is try to convert the string to an integer, right? So if it works, if conversion works, check for positive number. Okay, conversion fails, return false. So this one will return false when number is negative. Right, so if you look at this, does it seem to be better? Let's say if I put in -1, invalid integer format, okay? Put in 10, so you give me the factorial for that. Okay, so maybe integer invalid integer format, or okay, simply put, must be an integer greater than 0. Yeah, so this one will be better. Okay, so let's say if I run it again, must be an integer greater than 0. If I run it with 1.5, must be an integer greater than 0. I run it with ABC, must be an integer greater than 0. Is this easier to read for you rather than to put everything here? Yes or no? Okay, but basically it's supposed to do one thing at one time. You shouldn't do too many things at one time. Okay, you shouldn't do too many things at one time. It should be one thing at one time. So this is basically to return the factorial of a positive number. Okay, and this one is to return true if the string is a positive integer. So is this okay? Is it better? It's running.
Hi, sir. Can you please scroll up?
Is it better? As in, is the code better? Or is doesn't is better? Is it better because it's supposed to do one thing at one time? Okay, let me know if you're done. Okay. Done, huh? So what about the rest? Done. Nikki, okay? Okay, yeah. Right. So, okay, just the last part here. My file is called math functions. I know in the slides it's called Factoria. I prefer to call it a more generic name, so later on I can put in other functions as well. Okay, so what I'm going to demonstrate here is that if you've done proper documentation like this, first of all, okay, so you see something like this, right? Don't worry about this first. Let me try to help on the factorial. Right, so you can see return factorial of a positive number. Okay, help on math functions dot is positive integer. Return true if the string is a positive number. So you can see this one will help. Okay, but of course this is not supposed to be in this file. It should be used in other files. Okay, but anyway, it is to show you that you can actually, once you document your code properly, okay, you can do you can see that people can make use of your documentation. Okay, all right. If there's no questions, I will move back to the slides. Then I'll conclude the slides that itself, and then we'll go for a break. Come back, we will look at the examination paper, not examination paper, but the sample examination paper provided with the guide. Okay, so I'm going to go back to the slides. Okay, so based on the slides, we saw the help function. Okay, documentation is useful, helping other programmers to understand your code as well. Okay, you can try that and then run it, but like, yeah, you can see he did the try except here. Okay, when I really did the try except in the code, right? So he put all the checking over here, which I believe that if you agree with me, is going to make the code a bit more messy. Okay, it's actually going to make the code a bit more messy. Okay, right. So we'll adopt the other code there. Okay, so what's the big O notation for this? Is basically looping from 1 to n, so it's just on. Okay, it's just basically looping from 1 to n. Okay, so if it's 10, you have to do 1 times 2 times 3 times 4 until 10. If it's 100, it's 1 times 2 times 3 times 4 until 100. So it's definitely on. Okay, any questions on this particular example? Okay, I deviated from his because I find that there is no need to do a type error. Okay, we only need to do a value error. Okay, we only need to do a value error, and at the same time, I put all these validation outside of this particular function. All good. Any questions on this? My version is easier to understand for this example. Yeah, the other one is because I haven't completed the example, so it looks more difficult to understand. Later on, if I can, I will try to code one example and let you see, okay, and see whether it's easier to understand. Okay, for slide 19 onwards, I'm not going to go through this. This is matrix transposing. Okay, I did not come up with this in the exam. Okay, so that should help you a bit. Okay, so you can read it on your own. Okay, for not just because of exam, but maybe because you want to see how the algorithm works. Okay, you can try it on your own. Okay, how it actually works. All this actually works. Transposing is basically from row to become column. If it's column, becomes row. That's all. Okay with that? So this one I'll leave it to you. Is that fine? Because if we go through, we don't have time to go through with the study guide already. All right, okay. So shall we go for a break then? Shall we come back at 8:35? Is it all right? Yes, okay. So let's come back at 8:35.